Okay, as promised, one last video to talk about similarity. The only thing we haven't talked about similarity is similarity on the coordinate plane. This is also relates it back to our transformations. If you guys remember transformations from chapter 4, we had something we called rigid transformations. Now we're going to look at similar transformations, which really changes the shape, but the shape stays the same, and that's exactly what we've been working with. And so something that we're looking at here is up here is D is going to represent my scale factor. A prime is not my original shape, but it's there. If I let's see here, not that. If I move this down, there you can see A prime starts to show up, and then ABC is my original figure, with B being something that we're going to call the center of dilation. So that's what we're working with. The first thing I want us to see is that if the scale factor is 1, then the shape falls on top of the original shape. So congruent shapes are similar to each other. They have proportionate sides. It's just a scale factor of 1. Nothing exciting in there. And some stuff that we can see as we go down. We can kind of look at different scale factors. We can look at what's going on each of these as it grows and as it shrinks. And this is going to be something that that we want to do and what we want to look at. So what we want to see here is a couple different things. First off, if I go ahead, I'm going to do major and minor grid lines so we can kind of zoom in and see things at a half. So this would be 4.5. But the first thing I want us to kind of look at is just the fact that the center of dilation is where it's being grown from. And so all 3 of those points will fall in a line. And so if I go through A prime, see how A lands there as well? And if I go through C prime, C goes there as well. And if I go through D prime, D prime, B lands there as well. And it doesn't matter where I am, it almost looks like it's railroad tracks as it goes out. It just gets shrinked in and pushed in there. But that's just what we're looking at. And it doesn't matter where we move it. That is how we kind of can tell. So what I want to look at is I want to look at different dilations and where the points are going to end up. So if I come and let's just say that I go right here and put my center of dilation right there, I want to find out a couple different points here. Let's first make it smaller. If we know something, we know that the smaller value is going to make the shape come closer. And so one thing you're going to be asked to do is on the coordinate plane, find the point at which it is the scale with the scale factor of 1/2. Find the new coordinates for A prime, B prime, and C prime. So I can kind of do that just by counting. If I want to look at it being 1/2, then I am just going to count the X, count the Y from here, and I know that it's going to be half the distance along here. So right now I see that I am 1, 2, 3, 4, 5 away, and or 5 up and down, and 1, 2, 3, 4, 5 this way. So I'm going to take my line that I am in there, and I'm going to take half of 5 and half of 5 because that's what I want my scale factor to be. Half of 5 is going to be 2.5. And then I am also going to make sure that I'm sitting doing things right. So I go 1, 2, 3, 4, 5, 6. Oh, 6 this way. Okay, sorry. So half of 6 is 3, so I'm only going to go 3 away, and then I'm going to go up 1, 2.5. And I'm going to put a point right there just to kind of see what's going on. I'm going to keep on doing that. The distance from D to B is 2. Half of that is just 1. And I'm not going left and right, so I don't need to worry about it. Left and right, I'm going 1, so I'm going to be on the halfway mark, and I'm going to go 1, 2, 3, 4, 5, 6. Half of that is 3. And so I'm going to go 1/2, and then I'm going to go up 3 and be about right there. Now watch as I move my scale factor down to 1/2. It fits perfectly on there, except for my F point, which is not where it should be anyway. So my F point should be, that is only 1/2. I'm going to be up at 1. That's why that is. So I'm going to go ahead and move that up there, and I can see that I'm halfway there. A good thing to check is make sure you're in the line, make sure you're working that way. But let's say that we want to go larger. So maybe we scroll out just a little bit, and I see in here that I'm still going to go from D prime. And maybe let's go see how those points actually stay with it, which is kind of nice. Actually, no, they don't. I lied. They don't stay. It's not nice. But if I want to grow out that way, let's say. So now I'm going to go to C. And so now as I move from C, I notice that I am 1, 2, 3, 4, 5, 6, and 1 up. And so I'm going to go 12 over now from this point. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then since I only went up 1, I'm going to go up 2. A good rule of thumb is to always make sure that that line goes through there. So I'm going to go up here, and that's where that point should be. If I move this to the 2, it's right on that, and it's right on that point, which is perfect. And that's what I want to see. So we can go either way. We're just counting from the center of dilation. It doesn't matter where we put it. Notice that if I put the point right on D, the point is right there because the distance is 0. But if I go this far away, I can continue going down that line, and it's always going to be double the distance. If my scale factor is 2, my scale factor is 1.5. It's 1.5 times the distance. If it's less than it, it's smaller. But that's what you guys are going to be doing. On a test or anything, you'll be given something. This is not the best way to do it. You could be given something that doesn't have the lines in it. And so I would encourage you guys to first draw the lines through to see what's going on. So I chose Ray, and I went from there through the points. The other thing we're going to have to do that deals with that is that you guys will be given something that looks like this, where we have both of them already. And you want to find the center of dilation and the scale factor. So if I'm going to A prime, I know I'm getting smaller. By how much? So what we want to do is we just simply want to draw our lines through. And so I'm going to draw a line through A and A prime. I know the center of dilation is somewhere on this line. And then I'm going to draw another one through B and B prime. And right there, I can even do it through C and C prime just to show it. Right there is my center of dilation. So I know that my center of dilation is right here. That's the point that we're dilating through. And it's getting smaller, and let's kind of look at how much smaller. If I look at A to A prime, it looks like from E to A, I go over 6 and up 5. And from E to A prime, I go over 3 and up 2.5. Each of those distances are half of each other, so I know that the scale factor is then just 1/2. Because I'm getting smaller. If it was the opposite way, it'd be 2. Because A is my original, I'm going to A prime, it's getting smaller. So that's all you're really looking at with the coordinate plane. Use this. You will have some GeoGebras that you have to use on the test, or that you can use. You don't have to use them. You can use graph paper if you want, but some people don't have graph paper. But we're looking from here, we can look for center of dilations and scale factors just by counting and finding the intersection. So hope you guys have a great day, and next week we'll get ready for the test.